Hello. I'm audible now?
Yes,
Yeah,
ma'am.
now it's okay. Good
Ma'am.
morning.
Yes, madam.
Okay.
Thank you.
Okay. So today what we are going to see, we are going to see the concept called as modules. So let us say I'm a team lead in my company. My teammates are frequently writing the code for making the users register. My teammates are frequently writing the code to make the user register. So I have identified that as a reusable code, and I am writing the code. I am writing the code to make the user register. To reduce the burden of my teammates, I am only writing the code to make the users register. In the same way, my teammates are writing the logic regularly for making the users log in. I have identified that login functionality as a reusable activity, and I am writing the code for that login. Similarly, logout is also logout is also the reusable code I have identified. I have just written that code to reduce the burden of the teammates. And let us say turnover. Turnover is a reusable variable. So many clients are asking about the turnover. Let us say, so I'm creating a variable regarding, like I'm creating a variable called as turnover. In that, what I'm doing, in that I'm just putting the turnover of the company. Let us say like this. So where I'm putting all these things, I am creating a Python file called as harikatl, harikatl.py, harikatl.py. So in this harikatl.py, I will be putting these functions and variables. So see, this harikatl is called as a module. What is a module? Collection of reusable variables and functions. Collection of reusable variables and functions is called as a module. What is a module, you know? Name of the file is nothing but the name of the module. Name of the file is nothing but the name of the module. So file name is what here? Can you please tell me?
Harika.pl.
Okay, harikatl. So what is the name of the module?
Harika.tl.
Harikatl, correct. So remember, teammates will create the team leads will create the modules generally, and the teammates will use the variables and methods of the module. Okay, so let us say john.py. There is a file called as john.py. In this John is creating his own file to perform some activities. Actually, John has to make a user register. Now he will not write the body for register. He will just call me register function. He will just call me register function. John want to make a user logout. Then he will not write the functionality for the logout. He will directly call me logout function. He will directly call me logout function. Similarly, John has to display the turnover of the company. Now he can directly use my variable. So print the turnover of the company is, he can just write turnover. He can just write like turnover. Okay. So now see, actually John want to use the variables and methods of which module? harikatl module. harikatl module. So what John has to do, if he want to use the variables and methods of a module, he has to import my module. Import harikatl. Import module name. Import module name. See, importing means what? Bringing. All the variables and methods of harikatl module will also be loaded in the john.py file. All the variables and methods of harikatl will also be loaded into the john.py file. Now, this John can use any variable, any method from that harikatl, because all the things got loaded into john.py. What is the syntax to use the method from a module means? Module name dot method name here also. module name dot method name. So here also module name dot method name. Okay. See, I am telling that teammates will create the modules. Name of the file is nothing but name of the module. So it's a collection of reusable variables and functions. Now what teammates can do? Teammate can import the module. What is the syntax to import a module? Import module name.
Your name.
Yeah. So what is the syntax to call a method from a module? Module name dot method name. Yes, module name dot method name. And what is the syntax to call a variable from the module? Module name dot variable name. Correct? Module name dot variable name. So team leads will import the modules and will use the variables and methods of the module. But teammates will be creating the modules. So let us go with an example. Okay, so being a team lead, I have created a module called as calculator module. Calculator module. Right click, new, Python file, calculator module. See, module is a collection of only reusable variables and functions. So here I'm just writing x, y variables and add, sub, mul, div, square, cube, like that. I have created several variables and functions in the calculator module. Like this I have created. Okay. Now, John is my teammate. How can he use my module means? See, one thing you remember. First, this file has to be attached into his project. See, John has created one project. Into his project, he has to attach my module. I will either put the module in the shared folder, or what I will do, I will mail this module to the teammate. What he can do, see, let us say John has created the project sub p1, sub p1. So in from the mail he has downloaded this .py file. See, I told in the initial classes where all these will be stored, like where all the projects will be stored. Yes, the sub p1 will be in the C users user PyCharm projects, right? So he has to download the calculator module from his email. He has to go to C users user PyCharm projects. Here sub p1 is there now. He have to paste here. He has to paste the calculator module here so that he can open from here. Understood? He has to paste the module in his project. Then only he can create the respective files and he can use. Now he is creating a file called as john.py. And can you please tell me, if John want to use the variables and methods of calculator module, he have to import. How to import a module? Can you tell me please?
Import calculator module.py.
Yes, import calculator module. That's it. .py is not required. Anyhow, that's a file. Just so import calculator module we have to write. Okay. Uh, John want to use the sub function came from the calculator module. Can you tell me the syntax how to call a method?
Calculator module dot sub
Calculator
function.
module dot sub. Correct. Sub is accepting 2 arguments, so you are giving. So in the calculator module, you are calling the sub function with the 10 and 3. So 10 minus 3 is 7. Return. Return means I told you the cursor will go back to the calling place. The cursor will go back to the calling place with the value 7. To hold that 7, we are taking one variable like sub result. You know, return means where is the call to the same line the cursor will go. I told yesterday. So 7 will be stored into the sub result variable. And can you please tell me, I want to call the div function from the calculator module. Can you please tell me how can I do that? div function, div function.
Calculator module dot div function.
Calculator module dot div. It is taking two parameters 10 and 5. So calculator module div function 10 5. So 10 by 5 is 2. Return means what? It will go back to the calling place. And here you are taking div result equal to. So now please tell me, John want to print the value of x. How can he do that? Can you please tell me the syntax? Print
mname calculator module
dot x, right?
variable. Yes.
Yeah. Perfect. Okay. So from the calculator module, the x value 109 will be picked up and that will be printed. Now I'm running. Okay, even I have to print this and this. Print result. Okay, so see this one. Any doubt is there? Means let me know. Okay, fine. So can anybody give you a guess? See, because of this import, there are two problems. There are two problems we can say. So anybody can give any guess?
We have to give big name, lengthy name.
Yes, correct. Every time I have to give like module name dot, which is not good. Okay, this is the first problem. Second problem is whenever I'm writing import module name, let us say in calculator module 50 variables, 50 methods are there. Totally 100 members are there. Member means variable or method. So whenever I'm writing import calculator module, all the 100 variables and all the 100 members of the calculator module will be imported into John.py. But John is using how many? John is using only 3 subdiv x. John is using only 3. But how many are imported into the current file? 100. That means 97 members loaded unnecessarily. 97 members got loaded unnecessarily. It's like wastage of memory. The first problem is John is using only 3. But whenever you are writing like this, everything from calculator module will be loaded into John.py. That's the first problem. Second problem is every time it is very difficult for us to precede the name of the module at the time of call. Module name dot, module name dot, module name dot. It's really difficult. So in order to overcome these two problems, we have from import. If I use normal import, then these are the problems you are going to get. Instead of using normal import, what I will do? I will use from import. Say John 1. So what I'm doing here, from module name import. See, from calculator module import. Whatever John is going to use, those only he is going to import. See, to get the suggestions, you have to click on control space. Control space. So he's importing the add function, comma, click on control space. He's importing the, let us say, some square function, comma, he's importing x. Now, can you please tell me all the variables and methods from calculator module got loaded or only these 3 got loaded into john1.py file?
Only 3.
Only these 3.
Yes, first problem is okay, overcame. Now, the second thing is remember, whatever you are putting after from, that no need to put at the time of call. You kept the name of the module after from now. Now, no need for you to put that name of the module at the time of call. You can directly call the add function. To hold the result, you are taking add result variable. You can directly call the sub function. To hold the return value, you are taking square result. And you can directly call the variable. See, the two advantages means what? From module name, import whatever you want, only those will be loaded, everything will not be loaded. And whatever you are putting after from, that no need to put at the time of call. So calculator module dot is not required. You can directly call the functions and variables. You are calling the add function with the 2, 3. So 2, 3, 2 plus 3 is 5. Return means it will go back to the calling place with the value 5. And to store that, you are taking a variable add result. And you are calling the square function with the value 5. The value 5. So 5 into 5, 25. Return means what? It will go back to the calling place. And I have given some variables to a result. And then x. X means what? What is the value of x? X means sum. X means 109. So that will be taken. Now see. Okay, I have to print that add result.
The add square.
Correct. Print square result. Okay, fine. So like this, see, there are several modules available. So teammate can put several modules in his project and he can call any variable, any method from the module. That will be okay, not a problem. But see, small problem is again available here. I will tell you. A small problem is there. So let us say 3 team leads are there in the company. 3 team leads. First team lead has created a module called as arithmetic.py. Okay, and in that arithmetic.py, he have created some function like sum. Now the second team lead have created a module called as facttable.py, and he has created. See, in the arithmetic module, several functions are there like sum, sub, mul, do, which can calculate the sum, subtraction, multiplication, division, all such things. So there is one more module called as fact table. So this is created by the second team lead, and he has created some functions like factorial function and also the table function. See, fact function, if you supply a value to the fact function, it can calculate the factorial of that number. And table function, if you supply a value, it can generate the table for that particular number or value, whatever. Third team lead is that he's creating a module called as power.py. In the power.py, he has created the functions like square, cube, quad. If you pass the values, then it can get the square of the number, cube of the number, like that. Such type of functions are available. So that is fine. Now what I'm doing, see, John is a teammate. John is a teammate. This is fine. See, John want to use some function. Can you please tell me what import instruction John has to write if he want to use the sum function?
Import arithmetic.
From arithmetic import.
Import sum, or else let us say we are writing an import arithmetic. Okay, let us take directly for now. Okay, please tell me, John also want to use the fact function. What import instruction he has to write normally? Import fact table. Import fact table. Import modulo. John also want to use the square function. Then what import instruction he has to write? Import power. Okay, import power. See, let us say someone haven't muted. Please mute yourself. Okay. So John want to use 100 functions, but one function is from one module. Can anybody answer? If John want to use 100 functions and one function is there in one module, then how many import instructions he have to write? How many import instructions?
100.
100, correct? But it is very difficult. Importing, like writing 100 import instructions is very, very difficult. So what the team leads have decided, see, anyhow, these modules are related to each other. Anyhow, these modules are related to each other. So what they are doing, they are grouping these related modules into a package. They have created a package called as math. Anyhow, these are performing some kind of math operations. So they have decided like this. Let's group these modules into package called as math. So arithmetic, factable, power have been grouped into a package called as math. Now, see, this is not required. Now, if John want to use the sum factable square, then what he can do, instead of importing each and every individual module, he can import the package. Import math, import package name. Whenever John has imported the package, what will happen? He is free to use any module, any function from that particular package. If he imports the package, he is free to use any function, any module from that particular package. So import method means everything are available now in his file, in his john1.py file. Okay, now see how can he access the sum function? Arithmetic dot sum, module name dot function name, right? How can he access the fact function? Fact table dot fact. How can he access the power function? Power dot square. Correct? But see, actually, earlier these modules are independent modules, but now these modules are not independent modules. These modules are related to each other. These modules are related to each other, and they grouped under the package math. So what you have to do, what is the syntax to use a function from a module which is under a package? What is the syntax means? Package name dot module name dot function name. Package name dot module name dot function name. Package name dot module name dot function name. So what I am telling, if John imports the package, he is free to use any variable, any method from a module. So math dot arithmetic dot sum, package name dot module name dot function name. This is the syntax. So what is a package? Group of related modules is called as a package. Group of related modules is called as a package. Otherwise, there is one more definition. Folder. Folder with init.py file. Folder with init.py file is also called as a package. I will tell that point now. Okay. So what are the two definitions? Group of related modules is called as a package, and folder with init.py file is also called as a package. I will show what is that. Okay, let us go with an example. So I will create a new project for getting more clarity. Packs, something like that, whatever you want to take the name as the name of the project. Okay, so okay. See, I am creating a Python package with the name MyMath. In that, arithmetic is the module and these are the several functions. Factor table is the module and this function is calculating the factorial of the number, and this will generate the table of a particular number. So you see this. Okay, today I will send material. Na? Just try to understand this factorial logic and table logic. Table already we have seen in the loops. See this once. If you don't get, ask me tomorrow. Okay, but you will get it. So next, power function is power module is taking two functions, square and cube. So what is the package name I have taken? My math. In that, arithmetic, factable, power, three modules I have taken. Okay. So see how to create a package. Right click, new Python file, everything we are doing, right? Every time we are doing. Now it's not like that. Right click, new Python package. Right click new Python package. So name of the package is what? MyMath. See? Understood. Automatically a folder with the name of the package, that is MyMath, got created, and a file called as init.py will be created. Yes or no? I haven't created it. Automatically a file with the name init.py will be created in that MyMath folder or in that MyMath package. I will tell you what is the purpose of that. I will tell you. Now see, I am creating the first module in that arithmetic. Right click on the MyMath, new Python file. So in that I'm putting several functions, add, sub, product, and div. And then I'm creating one more module in that MyMath package, that is fact table. Right click, new Python file, fact table. Okay, and then power. Right click, new Python file, power, square and cube. Okay, fine. Now, please answer my question. As far as this arithmetic, fact table, power are the modules of MyMath, yes or no? These three are the modules of MyMath, yes or no?
Yes.
Yes.
Yes. Okay. But see, the problem is Python won't consider that these modules are under the MyMath package. That is the problem. It will not establish any relation between these modules and MyMath package. It is the responsibility of the programmer to put these modules in that MyMath package. It's our responsibility to put these modules under the package. How can I put the modules under the package? See, every package will have an init file, right? You have to open the init file. You have to open the init file of the package, and you have to put the modules. See, okay. See, now arithmetic. See, I am putting arithmetic into my math package. I am putting fact table into my math package. I am putting power into the my math package. Now, these modules are under the my math package. See, init means what? Initialization. You are initializing the package with the modules. Now I will ask you a question. I won't write this instruction. If I won't write this instruction, power will be the module of my math, or it will not be the module of my math.
It will not be the model.
Perfect. So whenever I'm writing in whenever I'm putting power into my math, then only this power is going to be under the my math. Otherwise, Python will not establish any relation between the power and my math. So you have to open the init file of the package and you have to initialize the modules in that. Then only these modules will be considered as the modules of this package. But see, actually, up to Python 3.7 or Python 3.7 or for lower versions, this problem is there. This step you have to do. But from Python 3.8 and above versions like 3.1, 3.2, 3.8.1, 3.8.2, this step is not required. Automatically, these modules are recognized. These modules are considered as the modules of the MyMath package. But up to Python 3.7, this step is mandatory. Otherwise, there is no relation between these modules and this package. But I am telling generally, because if you write this code in any version, it should work. Na? This is standard. This is standard. In all the versions, if you put like this, then there will not be any problem. Okay. So now arithmetic, fact table, power, 3 modules I have taken, and I have grouped them into the package MyMath. Now, being the team leads, they have arranged everything in a proper way. Now, teammate is there, John teammate is there. He can create john.py here, inside the package, outside the package, anywhere is okay. Right click on the project, new Python file. So, John. Now, he want to use the some function from arithmetic module or add function, import package name dot module name dot, yeah. Otherwise, we will directly do like this. We will use from import, right? So what is that? This is where this is more better, right? So from mymath dot arithmetic, click on control space to get the suggestions I told. Control space. So from mymath package, from arithmetic module, what he's using? He's using the add function, correct? Similarly, he also want from mymath package power module, he want to import the cube function. Now directly he can call the add function to capture the result. He is taking add result equal to, and cube function he can directly call. I will tell you why. So cube result equal to, I'm printing add result and also the square result. Sorry, cube result. Okay. So see, actually, add of 2, 3. That means you are calling the add function with 2, 3. So add function is from where? From arithmetic module. From which package? From the mymath package. So from mymath, from arithmetic add function you are calling with the 2, 3. 2 plus 3 is 5. Return means the cursor will go back to the calling place. So here is the calling place. So here 5 will be captured. Cube function you are calling. Cube is from which module? Power module. From which package? mymath package. So from the mymath package, from the power module, cube function will be called with the 9. So 9 into 9 into 9 will be returned to the calling place and it will be into the cube result variable. So you are printing the cube result. Just give me 1 minute. Okay, so see, now please let me know everything, all functions, all modules, everything are loaded or only add and cube functions got loaded here into his file?
Only add and cube.
Only add and cube, that is fine. And see, I told very clearly, whatever you are putting after from, that no need to put at the time of call. You are putting package name dot module name after from, na? So no need to put at the time of call. Whatever you are putting after from, that no need to put at the time of call. So no need for me to put package name and module name at the time of call. Okay. So fine. If it is normal input, how can you do? Import mymath. Again, mymath dot arithmetic dot sum. Mymath dot power dot cube. Like that. But that is not good. Again, mymath dot package name dot module name dot we have to give, right? That is not good, right? So that's why it's always better to use the from import. See this? So this is the problem with the normal input. Import mymath means what? Everything, all the variables, all the methods, everything from mymath are getting imported. All the modules, everything are coming. So module name dot package name dot module name, package name dot module name. Every time it is mandatory to write that. Definitely instead of this from import is far better. That's why I'm using the from import. So from import I have used. Okay, so now the next level we are seeing. See, actually, package is a collection of modules, right? So let us say there are some modules like M1, M2, M3, M1, M2, M3 in the package, and see, package can also have the sub packages. Package is a collection of modules and also the sub package. Sub package is also a package, na? So even it can have the modules, right? So M4, M5, like that. See, package is a collection of modules, but a package can also have the sub packages. Sub package is also a collection of modules. Please mute yourself. Someone have unmuted. See why generally we will prefer subpackage, you know. Let us say I am just creating a package with the name college. I am creating a module called as teachingstaff.py where I will be writing the functions related to the teaching staff. And I will also write something called as non-teaching staff.py. Here I will be writing the functions which are related to the non-teaching staff. Now I will take a sub-package called as departments. So in that sub-package departments, I will be creating a module called as csc.py where I will be writing the functions related to the CSC department, and then I will write triply.py where I will be writing the functions related to the triple department. See one thing, this college is a package and this is a sub-package. It's not at all a good idea to take departments as a separate package. No, departments is also for the same college only, right? Departments is also like it is belonging to the same college only. So it's a good idea to take departments as a sub-package of college. Okay, now you have to answer. If I want M1, M2, M3 to be the modules of this package, what I have to do? I have to open init.py of package, and what I have to do? Understood my question? I want M1, M2, M3 modules to be under this package. So what I have to do, I'm asking.
We have to import, madam.
Yes, I have to open the init file and I have to import M1 module, M2 module, M3 module. Yes or no? Correct. Now, see, if I want M4, M5 to be under the sub-package, what I have to do?
Yeah, you
have to open the init file of the sub-package and I have to import M4 and M5. See, one more step is missed. Can anybody please tell me? Even one more step is missed.
you have to link these two package
Import
sub-package.
sub-package.
Perfect. See, I want sub-package to be also under the package, right? So I have to open the init file of the package and I have to import sub-package also. Otherwise, again, the same problem. The sub-package is not at all there is no relation between that sub-package and package. So open the init file of the package, import M1, M2, M3 and sub-package. In the init file of the sub-package, you have to import M4 and M5. So see this ones, this is what we are implementing now. Okay. So let us create our own package. In that we will create our own modules and sub-packages. So again, for more clarity, I would like to create a new project. Subpacks 1. Create. Yes, in this window.
Ma'am, is it necessary to create always with this project in C drive, or else we can create anywhere else?
Anywhere. Fine. Okay. So what I am doing, I am creating a package called as what? Main pack. See, I have taken the name of the package as self-explanatory. So I have created a package called as main pack. So let me close the unnecessary things. Okay. So how can I create a Python package? So right click new, where I have to go? Can you please tell me if I want to create a package?
Python package.
Yes.
Package.
Click new Python package. Correct. So main pack. So we pretty well know that init file will automatically come because Python knows that we are going to put the modules in that. Okay. So now the first module is what? Sum main. Right click on main pack, new Python file, sum main, and in the sum main we are putting the sum function. Okay. Next one is what? Submain. So main pack, right click, new Python file, submain. So sub function I am taking. Can you please tell me what I have to do if I want to put these modules under main pack? What I have to do? Can you please tell me?
Anytime py we are
Into py.
Perfect. I have to open the init.py and I need to put those modules in that package. I am putting some main in the main pack and I am also putting the submain in the main pack. Now these two are the modules of the main pack. Okay. Now up to here I will create one accessing file. Right click new. Accessing means what? Using, right? So access one. So what I will do, from main pack dot, from package name dot module name import function, from main pack dot submain import sub. I am calling the sum function. I am calling the sub function. See, sum function is from where? Sum function is from the sum main of main pack. So in the main pack, in the sum main module, you are calling the sum 10 plus 20 will be 30. See, I didn't return, I have just printed. Okay, it's up to us, right? So 30 will be printed. You are calling the sub function. Sub function will be from the sub main of main pack. In the main pack, in the sub main, sub function will be called 10 minus 20 means minus 10 will be printed here directly. Okay. So here we already know. So whatever I am putting after from, that no need to put at the time of call. That is fine. And even whatever we are giving here, only those will be loaded. You are saving the memory. This is fine. Now I will create a Python package. I will create a sub package. What is that? Subpack. What is the name of the sub package? Subpack. So see what what I'm doing. Excuse me, just give me 1 minute. Okay, so now what I'm going to do, I'm creating a sub package with the name subpack. See, in the main pack, right click on the main pack, new. Now please tell me, I have to choose Python file or Python package? Which one I have to choose?
Python package.
Python package, because that is sub package is also a package. So now I am putting subpack. See, sub package is also a package and even it is going to have init file. Okay, but what I want to create a module in the subpack, div module subpack. I want to create a module called as div module in the subpack. So I'm taking self-explanatory names. Right click on the subpack, new Python file, div module subpack. And in that, I am putting one function called as div. I am putting one function called as div. See, in the div modules, I mean, in the div module subpack, you are putting the div function. And if I want this div module subpack to be under the subpack, what I have to do? I have to open the, have to open and have to import it. Yes. So what I'm doing, I am putting div module subpack under the subpack, in the subpack, and subpackage is under where? Subpackage under the main pack. See, I must give the parent package hierarchy, otherwise I will get an error. So you are putting the div module subpack under the subpack, which is under main pack. You are putting div module subpack under subpack, and this subpack is under main pack. So now the relation between this and this has been established. And what else is left? Can you please tell me? What else is left?
Main pack init.py we are importing.
Perfect. So what we have to do, we have to go to the init.py file of the main pack and we have to import the subpack. So main pack is there, init.py is there. So here I am putting. So now main pack is having two modules and one sub package. Sub main under main pack, sub main under main pack, and sub pack under the main pack. Perfectly arranged. Now second file we are creating, access to, just we are using accessing means access to. Now what is my requirement? In the main pack, sub pack is there now. In that sub pack, div module sub pack is there now. So there div function is there now that I want to call. So how I am doing that? Let us see. From main pack dot sub pack dot div module sub pack import div, and you are calling the div function. Right click, run file. See what I am telling. I am calling the div function. Where is div? See, in the main pack, in the sub pack, in the div module sub pack, I am telling the div is there. 10 by 20 0.5. I am directly printing. I am not returning, nothing wrong here. So this is the way. See what I am doing. How to access a function from a module which is under sub package. How can I do that? From package name dot sub package name dot module name import function name. I very clearly told you, whatever you are putting after from, that no need to put at the time of call. No need for me to give main pack dot sub pack dot div module sub pack, not required. Directly you can call the function. Okay. So from the parent package dot sub package dot module, you are importing the function and you are calling that function. So that's why we are getting 0.5 as the result. See, initially what we did, initially we have the functions alone, we have directly called them. Later on what happened, these functions were kept under the module. So module name dot function name we have called like that. Later on what happened, these functions are under the modules and these functions are under the modules and these modules are kept in a package. So package name dot module name dot function name we have taken. Later on what happened? Later on package dot sub package dot module dot function. That means what? See, initially only functions are there. Later on the functions got grouped in the modules. So later on functions are under modules, but modules are under the packages. Then what happened? Functions are under the modules, modules under the sub package under the package, sub package is under the package. So these are the 4 levels we can say. Functions alone, functions under modules, modules under packages, again modules under sub packages under packages. So this is the thing. Actually it is modules and functions and packages, sub packages are very, very important in real time. Okay. Okay then, fine. So the next thing what we are going to start is object oriented programming system. See, before starting object oriented programming system, I would like to tell you what is procedure oriented programming. In procedure oriented programming, the task to be done is divided into subtasks like subtask 1, subtask 2, subtask 3, and each and every subtask is called as a procedure.
Madam, I have a question.
Yeah, please tell me.
Please refer access one code, access one package.
Okay, access1.py. Okay.
Yeah. Here you are importing sum and sub in 2 statements. Is it possible to import in one statement? I'm Ashok Babu.
Okay, so you are telling the two things you are importing. See, one small thing you observe. Sub is from different module and sum is from different module. Na? So you have to literally write two instructions. If both the functions are from one module, then that's okay. But you are using different modules now, so you have to write different instructions.
Okay, madam. Thank you.
Fine. Welcome. Okay, so in procedure-oriented programming, the task to be done is divided into subtasks, and every subtask is called as a procedure. The procedure is nothing but our function definition. Our reusable blocks are there, na? The function definition, they are nothing but procedure. In object-oriented programming, also, the task to be done is divided into subtasks like subtask 1, subtask 2, subtask 3, and each and every subtask is called as a class. Each and every subtask is called as a class. I will tell you what is a class, but you may definitely have a question. Actually, we are discussing Python now. Why she's telling about object-oriented programming? Is there any relation between the Python and object-oriented programming? Means, yes, there is a relation. C language is not object-oriented. Java is object-oriented programming. Yes, Java is object-oriented. .NET is object-oriented. Python is object-oriented. See, how I'm deciding, how would I know whether a language is object-oriented or not? How would I know? Yes, I'll tell you. See, the principle is very simple. In any language, if we write the code using classes and objects, then we can call that language as object-oriented. In C, there is no concept of class or object. So C is not object-oriented. In Java, we will write the code using classes and objects. So Java is object-oriented. In .NET, we will write the code using classes and objects. So .NET is object-oriented. In Python also, from tomorrow's class, we will use classes and objects to write the code. That means in Python also, we can write the code using classes and objects. So we can call Python as object-oriented language. So in any language,
I have a question.
1 minute, just complete. Let me complete. Definitely, I'll answer your question.
Okay.
So, yeah. In any language, if we write the code using classes and objects, then that language is called as object-oriented. So in Java, in .NET, in Python, we will write the code using classes and objects. That's why we can call them as object-oriented. In C language, there is no concept of class or object, so it's not object-oriented. Okay. So that is a basic funda. Yeah. Someone have a.
Yes.
Please tell me.
What I want to ask is, in Python, is it necessary to write code using class?
Definitely. If we implement the object-oriented principles in Python, we can achieve data security, parallel processing, code reusability. Several advantages are there. Not only in Python, in any language, if we implement object-oriented principles, several advantages we can get. You know that one advantage is one topic. To achieve data security, we will use encapsulation. To achieve code reusability, we will use inheritance. So one advantage is one topic like that. Okay.
Oh, okay. Thank you.
Okay, fine. Okay. So this is fine. So that's what clearly I have written here. Any language, if we write the code using classes and objects, then we can call that language as object-oriented. So now, see, in the tomorrow's class, what I will do, I will tell you like this. Python is both object and procedure-oriented. I will substantiate that. Python is not only object-oriented, it is also procedure-oriented language, both. Okay, I will explain that point. See, I am telling that every subtask is divided, every subtask is called as a class. So what is a class generally? Class is a collection of variables and functions. Class is a collection of variables and functions. See, variables, attributes, properties, in any way you can call. Functions, methods, behaviors, in any way you can call. See, for example, if you consider the student class, then SNO, SName, SH, SAddress, SDepartment, all these will become the variables. Functions or reusable things means what for a student? Feed, join, reading, writing, etc. So class is a collection of variables and functions. class is a collection of variables and functions. Next, object. What is an object? Any real world entity is called as an object. Any real world entity is called as an object. It can represent a person, it can represent a bank account, anything it can represent. See, in order to clearly understand the difference between a class and object, I have kept this example. You will definitely understand now what's the difference. See, student is a class, student 1, student 2 are the objects in this context. See, class is like generalization. Generally, all the students should have what and what, that is represented by a class. All the students should have what and what, number, name, age, fee, join, reading. Generally every student should have what and what, that is represented by a class. It is simply generalization. See, student 1 is an object that is representing only the student with the number 101. Student 2 is an object that is representing only the student with the ID 102. Student 1 is not representing regarding everybody. It can represent only one particular entity. One object is used to represent one record or one particular entity. Student 1 is only representing regarding Anushka. Student 2 is representing only regarding Akhil. See, can you please answer, if I want to store the information, if I want to maintain the information of 5 employees, how many objects I have to take?
5.
5. Very good. See, if I take one object, let us say in E1 object, I am maintaining like this. ENO equal to 101, E-name equal to Ravi, E-address equal to US, like that I have written. If I write the second student information in the same object, like what will happen? The first object, the first employee information will be overridden, right? So if I try to store the second employee information in the first object, then already existing data, the first employee data will be lost, but I want that also. So that's why I will take 2 objects to represent 2 employees data, to represent 2 employees. See, one object is going to represent only one particular entity. Student 1 is representing only regarding Anushka. Student 2 is representing only regarding Akhil. But student is not like that. Class means generally all the students will have what and what, should have what and what, that is represented. Object is a real world entity. Yes, the student is really available. That's why we are maintaining his data. So student 1 object is representing only Anushka. Student 2 object is representing only Akhil. Please answer my question. I want to store the products, 5 product information, 5 products information. How many objects are required? 5 objects, right? So please remember, one object can represent only one particular entity. That's it. One object, only one record. That's it. So this is the difference between a class and object. Class is like generalization. It is going to represent regarding everybody, and one object is going to represent one particular entity. Okay. So fine then. A small question for you. So can I send one? Actually, after the discussion on this, before going to the principles of OOPS, I will be telling one topic called as special data types, that is list, set, tuple and dictionary. So to explain that, you need to have some introduction for that, the 20 minutes. So shall I send the video of this, or you want me to explain directly in the class? What is the thing? If you listen this 20 minutes video before the tomorrow's class, or in 1 or 2 days if you finish this, I will tell this directly. So will you listen this 20 minutes video, or shall I tell in the class? What do you say?
Please send video.
Video.
Video is okay.
Video is fine.
Okay. So even my intention is like to cover more as much as possible, because the duration is less now. So even I want to cover more. Okay then. So today what I will do, along with this material, I will send that video also. Please listen that, and we can directly start the special data types in the once the OOPS system. We can directly start this. Okay then. So any doubts for today's class?
Yeah, ma'am, one question.
Yeah, please.
Suppose if we install any package,
Mm-hmm.
it's a new package, then how to see what are the functions are available in that package and what are the modules are available?
Same na. If you put package name that, it is automatically showing.
All at a time. Suppose if you want to use that package perfectly, just we need to know all the functions that are available in that package, which we don't know.
The same thing I'm telling. See, if you put a dot, let it be predefined package, let it be normal package. If you just put a dot, it will show everything. Everything it will show. Okay. Even there are several other options. With the dot you can do. if you want to print the list, so let me do here. If you can see my material, it will be available. See, if you give something like this, dir of module name, let us talk about the module initially. Dir of module name, if you give, what it will do, it will print the list. It is showing here, instead of showing what it will do, it will print all the list of variables and methods created by the team lead in the module. Dir function we can have. So let us see let's go back to our calculated module once. I will tell you. See, such extra points are there in the material. Okay, you can check in the material. So, see here I have written. See, to see all the members of a module, dir of module name, that you can do. And even you can apply the help function. See, if you give help of module name, then what will happen, all the variables, all the methods, everything you can see. See, help on if you give help of module name, this will be the output. It will put like this: help on calculator module name, description, functions, data, the location of that module, everything it is showing. Okay, please refer my material. You will get such type of points.
Okay, thank you.
Okay then. So, any other doubts are there, or it is okay?
Madam, actually, these all the packages and modules and access programs should be in same folder.
Yes, definitely. Yes, definitely. Within the same project, there should be. You have to download the modules given by or you have to download the package from your mail, or you can collect that from shared folder, and you have to attach to your project. Then only it is going to work. Okay.
All should be in individual files, or it should be in subfolders also.
Anything is okay, but you have to make sure, before you access them, you have to make sure that they are available in your project. Then only they are recognized.
Thank you, ma'am.
Okay, fine then. Okay, then let's connect tomorrow then. Okay, I'll share the video and also the material. Okay, bye for today.
Thank you, ma'am.
Thank you, ma'am.
Okay.